Two identical rollers, each of weight 200 Newton, are placed in a notch as shown in figure with all the contact surfaces as smooth. Determine the reaction developed at all the contact surfaces. Okay, so two spheres are there, identical rollers are there. Okay, and they are inclined at 30 degree. So they are inclined at 30 degree. ಸೊ ಆಮೇಲೆ ಎರಡು ಐಡೆಂಟಿಕಲ್ ರೋಲರ್ಸು. ಸೊ ಇದ್ರ ಸೆಂಟರು ಈಕ್ವಲ್ ಇರುತ್ತೆ, ಮೀನ್ಸ್ ಅದೇ ಐಡೆಂಟಿಕಲ್ ಪ್ಲೇನಲ್ಲಿ. ಸೊ ಇದೇ ಐಡೆಂಟಿಕಲ್ ಪ್ಲೇನಲ್ಲಿ ಇದು ಸೇಮ್ ಇರುತ್ತೆ. ವೈ? ಬಿಕಾಸ್ ದೇ ಆರ್ ಇನ್ಕ್ಲೈನ್ಡ್. ಸೊ ವೇಟ್ ಆಫ್ ದ ಈಚ್ ಪೇರ್ ಇಸ್ 200 Newton. ಓಕೆ, ಸೊ ಐ ವಿಲ್ ರೀರೈಟ್ ದ ಫಿಗರ್ ಹಿಯರ್. So I have rewrite the figure. So what we have to find? We have to find the reactions at all the contact surfaces. LL contact ಆಗಿದೆ, AL ಆಗಿದೆ, BL ಆಗಿದೆ, next CL ಆಗಿದೆ, next DL ಆಗಿದೆ, next okay ABCD is the contact surface. Now because of this is 30 degree, I'll just take a parallel here. So this I'll just join their planes. Okay, now ಇದು 30 degree ಇದೆ. ಓಕೆ, ನಾವು ಈಗೇನು ಮಾಡ್ತೀನಿ, ನಾನು ಇಲ್ಲಿ ಸೊ ಪ್ಯಾರಲಲ್ ಲೈನ್ ಇದೆ. ಸೊ ಐ ವಿಲ್ ಟೇಕ್ ಅ ಪ್ಯಾರಲಲ್ ಟು ದಟ್ ಪ್ಲೇನ್. ನೆಕ್ಸ್ಟು ಈ ಪ್ಯಾರಲಲ್ ಲೈನಿಗೆ ಇನ್ನೊಂದು ಪ್ಯಾರಲಲ್ ಲೈನ್ ಹಾಕೋತೀನಿ ಅಲ್ಲಿ at the center of the identical rollers. ಓಕೆ, ಇಲ್ಲಿ ಹಾಕೋತೀನಿ. ಸೊ ಇದು 30 ಡಿಗ್ರಿ ಆಗಿರೋ ಕಾರಣ ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ವಾಟ್ 30 ಡಿಗ್ರಿ, ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ 30 ಡಿಗ್ರಿ, ರೈಟ್? ಓಕೆ, ನೆಕ್ಸ್ಟ್ ನಾವೇನು ಫೈಂಡ್ ಮಾಡಬೇಕು? ರಿಯಾಕ್ಷನ್ ಇಲ್ಲೊಂದು ಫೈಂಡ್ ಇದೆ. ಸೊ ಆರ್ ಡಿ, ರಿಯಾಕ್ಷನ್ ಆರ್ ಬಿ, reaction RA, okay, and also reaction at RC. okay, allal reaction find ಮಾಡಬೇಕು. So let us assume this as center as O1, this center as O2. So similarly we'll take, so FBD, free body diagram at O1. okay, so O1 ಸೆಂಟರ್ ತೊಗೋತೀನಿ. ಸೊ ಯಾವ್ಯಾವ ಫೋರ್ಸ್ ಇದೆ ಅದನ್ನಷ್ಟೇ ತೊಗೋಬೇಕು. ಓನ್ಲಿ ದ ಫೋರ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್. ಸೊ ವಿ ನೋ ದಿಸ್ 200 Newton ವೆಯ್ಟ್ ಇದೆ ಅಲ್ವಾ, ದಿಸ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಡೈರೆಕ್ಟೆಡ್ ಟುವರ್ಡ್ಸ್ ದ ಗ್ರೌಂಡ್, ರೈಟ್? ಸೊ ಐ ವಿಲ್ ಟೇಕ್ ದಿಸ್ 200 Newton first, then we will take RD. so RD is, so I already take in this already one, so I will make this going upward. So I will take the tail here and in that direction only I will make. So this is RD, so head to tail, so only tails are connecting. Now another force is RC. if I take RC here, then head will be connecting. So what I'll make, I'll take this RC as this, so RC. okay, same force what we are doing, just we are connecting the like terms. okay, now the angle, this one, so RC, where it is joining? No, this is the RC because it has same centers, identical spheres. what is this angle? This angle is 30 degree. okay, so this is 60 degree because the total is 90, so it is 90. what we want now, by applying Lami's theorem, what we do by applying Lami's theorem, okay, this 200 Newton divided by sine of opposite angle, that is, okay, we also want this angle. so at what angle the weight is applying on this sphere, it is also 30 degree. so it's given 30 degree. okay, so 30 degree plus 60 degree, it is total is 90 degree. so sine 90 degree, which is equal to RC divided by this angle. so this is 60 plus 90, 150 degree, which is equal to RD. RD divided by what? This one, 30 plus 90 sine 120 degree. Now as usual we will find RC. How to find RC? Just cross multiply 150 into 200. 150 into means, sorry, it is sine 150. Sine 150 into 200, it is divided by sine 90. So it is 100. Newton is the RC force. So similarly RD is equal to, how to find RD? 120 means sine of 120. Please don't neglect it. Okay, so sine of 120 into 200 divided by sine 90. So sine 120 into 200, it is 173.20. 173.20 Newton. Sine 90 we know, that is 1. So we have found RC and also RD. Now we will take FBD at O2. We'll take FBD at O2. So what we can take? See here, I'll write here. So I'll take, first I'll write the weight. How much is the weight? 200 Newton. Next here RC is there, so I'll write RC here only. Before we will see what are there. RA is there. Okay, RA is, this is inclined. Here we are not taking inclined, here we are taking the water. What is the force acting on that figure? Okay, so RA force is, so it is left to right. Okay, I'll take from here. So left to right I will take this RA force. Then what are the force? Then RB, here B is there, so I'll take RB, that is inclined to 30 degree, right? So I'll take RB. So this will be the my RB. Next what we have? RC. So we have to take RC like this, right? So for this circle it will be like this. So RC will be like this. So now we will apply the axis. So we know this is 30 degree. Okay, and this is also 30 degree, because if it is there, this will be 30 degree, so it will be opposite angles, 30 degree. Okay, RA, RC, RB 200 Newton. So we will apply the equilibrium concept. What is that? Sigma H equal to 0, summation of V equal to 0. So before that we have to resolve the forces for RB and RC. ಸೊ ಇನ್ನೂವರೆಗೂ ರಿಸಾಲ್ವ್ ಗೊತ್ತಾಗಿಲ್ಲ ಅಂದರೆ ನೋಡಿರಿ, ಪಾಯಿಂಟ್ ಇದೆ, ಪಾಯಿಂಟಿಂದ ಆರ್ ಬಿಗೆ ಮೇಲೆ ಹೋಗಿದೆ. ಓಕೆ, ನಾವು ಆರ್ ಬಿ ಅನ್ನೋ ಫೋರ್ಸ್ ಇನ್ಕ್ಲೈನ್ಡ್ ಇದೆ, ಅದನ್ನು ಒಂದು ಹಾರಿಜಾಂಟಲ್ ಆಗಿ ಮಾಡ್ತೀವಿ, ಒಂದು ವರ್ಟಿಕಲ್ ಆಗಿ ಮಾಡ್ತೀವಿ. ಸೊ ಹಾರಿಜಾಂಟಲ್ ಆಗಿ ಮಾಡೋಕ್ಕೆ ಎಲ್ಲಿ ಆ್ಯಂಗಲ್ ಇರುತ್ತೆ ನೋಡಿ. ಸೊ ಇಲ್ಲಿ ಆ್ಯಂಗಲ್ ಇದೆ ಅಲ್ವಾ, 30 ಡಿಗ್ರಿ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಆ್ಯಂಗಲ್ 30 ಡಿಗ್ರಿ. ಸೊ ಆ್ಯಂಗಲ್ ಇರೋ ಕಡೆ ಏನಾಗುತ್ತೆ? ಆರ್ ಬಿ ಕಾಸ್ 30 ಡಿಗ್ರಿ ಆಗುತ್ತೆ. ಓಕೆ, ಇದೇನಾಗುತ್ತೆ ಆ್ಯಂಗಲ್ ಇಲ್ಲದ ಕಡೆ? ಆರ್ ಬಿ ಸೈನ್ 30 ಡಿಗ್ರಿ. ಸೊ ಇಲ್ಲೇನಾಯಿತು, ಆ್ಯಂಗಲ್ ಇಲ್ಲಿರೋ ಕಾರಣದಿಂದ ದಿಸ್ ಈಸ್ ಹಾರಿಜಾಂಟಲ್ ಮೆಂಬರ್ ಆಯಿತು, ಇದು ವರ್ಟಿಕಲ್ ಮೆಂಬರ್ ಆಯಿತು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ? ಆರ್ ಸಿ ಇದೆ ನೋಡಿ. ಸೊ ಅದೇ ಪಾಯಿಂಟಲ್ಲೇ ಆರ್ ಸಿ. ಸೊ ಇದು 30 ಡಿಗ್ರಿ. ಇಲ್ಲೇನಾಗುತ್ತೆ? ದಿಸ್ ಆರ್ ಸಿ ಆ್ಯಂಗಲ್ ಇಲ್ಲೇ ಇದೆ, ಕಾಸ್ ತೀಟಾ ಆಗುತ್ತೆ. ಸೊ ಇದೇನಾಗುತ್ತೆ? ಆರ್ ಸಿ ಸೈನ್ ತೀಟಾ. ಸೊ ದಿಸ್ ವಾಸ್ ಅಬೌಟ್ ದ ರಿಸಾಲ್ವ್ಮೆಂಟ್. ಸೊ ನಾವು ಈ ಫೋರ್ಸ್ ತೊಗೊಳಲ್ಲ, ರಿಸಾಲ್ವ್ಡ್ ಫೋರ್ಸಸ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ. ಓಕೆ, ಸೊ ನಾವು summation of horizontal forces equal to 0, taking left to right as positive. Okay, now take the horizontal forces. RA RA ಲೆಫ್ಟ್ ರೈಟ್ ಪಾಸಿಟಿವ್ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಯಾವ ಫೋರ್ಸ್ ಇದೆ, RA ಒಂದು ಫೋರ್ಸ್ ಆಯಿತು, ಮತ್ತು RB ಇದೆ. RBದು ಹಾರಿಜಾಂಟಲ್ ಫೋರ್ಸ್, ಸೊ RB ಸೈನ್ ಥೀಟಾ, ಬಟ್ ಇಟು ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ. ಓಕೆ, RB ಸೈನ್ ಥೀಟಾ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಯಾವ ಫೋರ್ಸ್ ಇದೆ, RC ಫೋರ್ಸ್ ಇದೆ. RC ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ ಈಸ್ ಹಿಯರ್ ಮೈನಸ್ RC ಕಾಸ್ ಥೀಟಾ ಈಸ್ ಈಕ್ವಲ್ ಟು 0. ಎನಿ ಫೋರ್ಸ್ ಬಿಟ್ಟಿದ್ದೀವಾ, ಯಾವುದೂ ಇಲ್ಲ. ಫೈನ್. ನಾವು ಮೇಲ್ಗಡೆ ಏನು ಕಂಡುಹಿಡಿದಿದ್ವಿ, RC ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿದೀವಿ, ದಟ್ ಈಸ್ 100 ನ್ಯೂಟನ್. ಸೊ ಇಲ್ಲಿ 100 ನ್ಯೂಟನ್ ಹಾಕ್ಬೋದು. ಓಕೆ, ದಿಸ್ ಥೀಟಾ ಅಲ್ಲ, ದಿಸ್ ಈಸ್ 30 ಡಿಗ್ರಿ. ಓಕೆ, ನಾವು RA ಮೈನಸ್ RB sin 30 degree. RC value we know 100 Newton, so cos 30 I will write. Okay, RC cos 30 degree is equal to 0. So RA is RA minus RB sin 30 under is to 0.5. So 0.5 into RB minus RC we know 100, cos 30 is 0.86 into 100, it is 86.60 is equal to 0. So RA minus 0.5 RB is equal to 86.60. Take this equation as 1. Now summation of vertical force is equal to 0, taking upward as positive. Okay, taking upward as positive. So I can write in next page, but again for diagram I have to come back. Therefore see here, I'll write the equation only, I'll solve in the next page. So what are the vertical forces? 201 forces is vertical, RC vertical, RA the RB the vertical component. So we have three forces. So what will be 200 Newton, but it is not 200, it is minus 200. Then minus RC sin theta, then it is upward, right? RB component is upward, so that is plus RB cos theta is equal to 0. So what it will be, so I am taking theta, take it as 30 degree only, direct value you take. So what it will be, I will write, first I will write positive terms, RB cos 30 degree minus RC sin 30 degree is equal to 200. Okay, I'll take this equation in the next page. So what is the equation? So RB cos 30 degree RC sin 30 degree is equal to 200. So solve it fully. So cos 30 degree, cos 30 degree is nothing but the cos 30 is 0.866 into RB. RC we know that is 100, so 100 into sin 30, it is 50 is equal to 200. So RB we will get how much, 200 minus 200 plus 50. So when it goes that side, it will become 200 plus 50 divided by 0.866. What is the value of RB? RB will be 288.68 Newton. So this value in the equation number 1, what we get? So RA minus 0.5 RB is equal to 86.60, right? Now RA we want, so 86.60 plus 0.5 into 288.68, which will fetch you 288.68 into 0.5 plus 86.60. Your RA will be 230.9 94 Newton. So we find what we found out. Ra we found out, Rb, Rc and Rd, all the reactions at the contact surface were found. So this was one of the example. So we'll see the last problem now. So the last problem of this lecture, see. So two smooth circular cylinder, each of weight 1000 Newton and radius 200 mm, are connected at their centers by the string AB of length 400 mm and rest upon the horizontal flow. Supporting above them in another cylinder of weight 2000 Newton and radius 150 mm. Okay, two spheres are there. Determine the tension in the string and reaction developed at the contact surface. Okay, I'll read again. Two smooth circular cylinder, each of weight 1000 Newton and its radius is 200 mm, are connected. So these are two cylinders, circular cylinder of 1000 Newton, radius 200 mm, are connected with the string of AB, length AB, and the length AB string and its length is 400 meter and rest upon the horizontal flow. So supporting them another cylinder is kept on that with the weight of 2000 Newton and radius 150 mm. So determine the tensions in the string and reaction developed at the contact surfaces. So I'll write this figure, given figure in this book. Okay, wait. So see here, this is the figure. Okay, I have redrawn it. Okay, this you leave it. So two circles, two cylindrical spheres. I have given you the PDF. In that you can see the question again. Okay, two circles are there. So these are identical circles. Before, above that another circle is there. So that circle radius is 150. So identical circle radius is 200. So I have taken 200 radius, 150. So weights are given for each these identical circles, 1000 Newton, 1000 Newton. So it is 2000 Newton is the weight. Now we have to find the tension in the string and also the reaction at the contact surfaces. So two contact surfaces, 3, 4. So we have to find the contacts reaction at the contact surfaces. So what we can do now, so see here. So as this is 400 Newton, I'll take one imaginary line here. So obviously it is at the center. Okay, and it would be, this would be 200 mm, this is be 200 mm. So we got a triangle here. Okay, so why I am doing like this, because I want theta here. I want to find the theta. So theta is equal to, so we know this is 200 mm. So adjacent and hypotenuse we know, so it is directly come to the cos. So cos inverse of, okay, cos inverse of this adjacent angle first, 200 divided by 200 plus 150, 200 plus 150, it is 350. So 200 by 350, that is of cos inverse is, so theta is 55.15. So this was about the theta. Now we can take the free body diagram at O1. So I will take this as O1. Okay, so if I take the free body diagram at O1, what we will get? So take this as center. Okay, what is the weight here? 2000 Newton, right? So 2000 Newton. Okay, 2000 Newton. Then what are the forces are there? Now see here, another important thing I'll tell you. So this is the circle. So at here we have to find the reaction. So I'll take this reaction, I'll name just, this is as C, this is as D, this is as E, and this is as F. Okay, C, D, E, F, and this point will be A and B. this is O1. So for this sphere, for the sphere at here, the reaction will be like this. RC reaction will be like this, outer reaction. Okay, and for this sphere, RC will be like this from the outer. So for this sphere, RC will be like this. Okay, for this sphere, RC will be like this. So what I am going to do, so RC, right, I'm taking again tail to head, so I will take RC as like this. After RC, what we have to take, then we have to take what, RC and again is D. So D reaction will be like, so this is the surface, so this is normal to that surface, so like this. Okay, so tail is here, head is here, so I'll write in the same alignment here. Okay, RD. So RD I'll take in this direction, so here tail, here is head, so RD. Okay, see here in this figure, sphere is like this. Okay, RC, C point is here, D point is here, so C point will be like this. Okay, normal to the surface reaction. D is also normal to this surface. Okay, because of the calculation of what I will do, I will take RC like this, and I will take, so this will be RC, this will be RD. Again another one is the weight, that is 2000 Newton. Okay, I'll introduce the what, axis. Now we have to find the theta. Already we have find theta, that is 55.15 degree. Now from the same, from our PUC, see, if two lines are parallel, then if this is theta, this is also theta. Same way, I'll assume an imaginary line parallel here. Okay, so this parallel is nothing but this one. Okay, this parallel. So if this is theta, if this line goes on, so this line is nothing but what, your RC. So this will be also theta. So what is theta? 55.15 degree or 55.15. Okay, now similarly, if we observe this triangle is an isosceles triangle, because these two circles are what, identical. So radius is also same, so same, two sides are equal, means they are isosceles, right? So two angles will be, if this is theta, this theta is also 55.15 degree. So if this is 55.15, same concept, this will be 55.15 degree, 55.15. Okay, so we have three forces. So what we want here, we want this force, this full force, this full force, to apply Lami's theorem. Now we will apply Lami's theorem. Okay, we will apply Lami's theorem. Okay, see here, before we will calculate all the angles. So 90 minus 55.15, it is 34.85. what about this, same 34.85. so 34.85, it will be 69.7. so what is this, this is nothing but 90 plus 55.90 plus 55.15, it is 145.15. so it will be same 145.15. now by applying Lami's theorem, so by applying Lami's theorem, what is that, how we define Lami's theorem, force divided by sine of angle between the other two forces. So I'll take a force 2000 Newton divided by sine of angle between other two forces, means 69.7, which is equal to RC divided by sine of 145.15, then RD divided by sine of 145.15. Now we can find RC and RD by previous methods. How? So I'll write directly RC is equal to, so once you know the concept you can solve it directly. Okay, see RC is equal to, so RC into this one, this into this, so I will divide 2000 into this, divided by sine 69.7. so I'll take sine first, 145.15 into 2000 divided by sine 69.7. so our answer will be 1218.54. 1218.54 is Newton. Similarly, your RD is equal to, okay, so 2000 into sine 145.15 divided by sine 69.7. most probably same we will get 1218.54 Newton. So RC and RD we got same. Now what we should do, we have found the contact surfaces at C and D. What are remaining? We have to find T, we have to find E, we have to find F. So we will take another free body diagram at A. Okay, so FBD at A. So I'll take here FBD at A. So this is your A point. Okay, see here, this is A point. I will write here for your understanding. So I'll take this point as A. So I'll take first is weight 1000 Newton. Then we have RE. Okay, this RE is normal to the face, means how it will be like this. So already we have tail is here, head is here, so I'll take it upper. So this is RE. Okay, then which are the forces are there? Here RC is there, right? So RC will be for this, it will be from outside. So I will take here in the same direction, take RC. Okay, now apply the axis. We know that this angle is 55.15 degree by same concept. Okay, so we have RE we have to find. Okay, then what we can find? Yes, only RE we can find, and here we have to also find T. So this is nothing but the force T. 1 2 3 4. So we have 4 forces, so we can't apply Lami's theorem. So I will write this figure in the next page. Okay, wait. So I have written in the next page. Now 55.15, this is what FBD at A. So we'll apply, we can't apply the Lami's theorem because there are already 4 forces. Okay, because there is already 4 forces, so we can't apply the Lami's theorem here. Sigma H equal to 0, taking left to right as positive. So when you write this, you should come to your mind that any inclination force are there or not. So we have one inclination force, we have to resolve this. How? So direction is downwards, one will come here, that is RC sine, and again angle ಪಕ್ಕದಲ್ಲಿರೋದು RC cos ಆಗುತ್ತೆ. So RC cos 55.15, here another force RC sine 55.15. okay, fine. Now sigma H equal to 0, taking all the horizontal force equal to 0. Okay, taking left to right as positive. What I will do, I will first take T as it is positive, T. Next minus RC cos 55.15. then what we have, any other forces, horizontal forces? No. Then what we have to do, then T is equal to this RC cos 55.15, which is equal to, we have already find what RC is 1218.54, right? So RC is 1218.54 into cos 55.15, so it is 0.571. so your T will become 1218.54 into 0.571, so 695.7 ಅಥವಾ 78 Newton. So we found T. So we, in all the forces we have to find also the T. So we got the T. Now summation of vertical forces equal to 0 taking upward as positive. So what are the upward forces? So RE is upward, so no problem, it's positive. Next, minus 1000 Newton minus RC sine 55.15. Another force, no forces, 0. Then RE is equal to 1000. I will take that side, 1000 plus RC 1218.54. So sine 55.15, it is 0.802, 0.820. So now calculate 1218.54 into 0.820 plus 1000, it will be 1999.20 Newton. So the force RE is 1999.20 Newton. So what are that we have to find? We have to find RC, we found it. RD, we found it. Then RE, we found it. T, we found. What is remaining? RF. Okay, for this RF, what I do, see, so we got RE. Now we have to find RF. So by common sense we can tell that if RE is 1999.20 Newton, RF will be same, 1999.20 Newton, because they are identical, angles are same, distances are same, so same force will be experienced by both the points here, both the points. So if this is RE is 1999.29, this will also will be same RE. I'll show you by solving if you want. Okay, so what to do to solve? Just I'll take FBD at B. I'll take FBD at B. So what are the forces I am getting? I'll get 1000 T, RD and RF. So this is B, I'll get 1000. Okay, so T will be this side. Now T, same opposite of that, FBD at A you will get. Okay, FBD at A is there, no? So here RF, then the other force is RD we will take here. So I'll apply the axis, this is 55.5 degree. So all the values we know, we just have to compute. So just we will take where RF will come. RF is an what? Vertical force. So I will directly do one thing. It is summation of vertical force equal to 0 taking upward as positive. This is for only the checking purpose. Okay, already we got this by common sense, but I'll prove you how now. So I'll take only the vertical forces. RE, because it is positive, minus 1000 then this is RD, right? Yes, RD. So the vertical component will be RD sine theta, right? RD sine 55.15 is equal to 0. Now, sorry, this is RF. Okay, now RF is equal to, I'll all transfer all to that side, R 1000 plus RD sine 50.15, therefore 1000 plus 1218.54 into sine 0.820. Same, you see here we got the same. See the with this value, this is same. So RF will be 1999.20 Newton. So this is how we solve the problem for the equilibrium and Lami's theorem concept. Okay, we will solve another one, last problem. Okay, so see here, the collar of weight 264.4 Newton slides on a frictionless vertical rod and it's connected to 294 Newton counterweight. Okay, determine the value of height h for which the system is in equilibrium. So this is the system is in equilibrium. So il problem nodi enante. So this system is connected to a crane. Okay, so this is the crane. Okay, and this is the weight which it is experiencing. Okay, ಏನಿಲ್ಲ, ವೇಟ್ ಎಷ್ಟಿದೆ 264.6 ನ್ಯೂಟನ್. ಸೊ ಇದ್ರ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು 375 mm ಈಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್. ಸೊ ಈ ಥ್ರೆಡ್ಡಲ್ಲಿ ಟೆನ್ಷನ್ ಎಷ್ಟಿದೆ 294 ನ್ಯೂಟನ್ ಇದೆ. ಸೊ ಅವ್ರಿಗೇನು ಬೇಕು, ಎಚ್ ಕಂಡುಹಿಡಿಬೇಕು. ಸೊ ಹೈಟ್ ಎಷ್ಟು ಹೈಟಿಗೆ ದಿಸ್ ಸಿಸ್ಟಮ್ ವಿಲ್ ಬಿ ಇನ್ ಇಕ್ವಿಲಿಬ್ರಿಯಮ್. ಸೊ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಸಾಲ್ವ್ ದಿಸ್. Okay, this can be solved by the Lami's theorem on all or equilibrium of force concept. Okay, so we will solve by the equilibrium of force concept. So see the diagram. Understood what is diagram is? So this is the collar of weight 264.6 Newton. This is the collar of weight. So it is connected by the crane. Okay, this weight is connected by the crane 294. So the weight is experienced by this. Okay, here point. So ಜಾಸ್ತಿ ತಿಳ್ಕೊಬೇಡ್ರಿ. ನೋಡಿ, W is equal to 264.6 n. ಇದರದ್ದು ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿದೆ 375 mm ಇದೆ. ಸೊ ಟೆನ್ಷನಲ್ಲಿ ಥ್ರೆಡ್ಡಲ್ಲಿ ಟೆನ್ಷನ್ 294 ಇದೆ. ಸೊ ಹೈಟ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾನೆ. ಸೊ ಐ ವಿಲ್ ಸಾಲ್ವ್ ಹಿಯರ್. ಐ ವಿಲ್ ಗೈಡ್ ಯು. ಯು ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್. ಓಕೆ, ಸೊ ಐ ವಿಲ್ ರೈಟ್ ದ ಸೇಮ್. I have written the same diagram. Okay, 375 mm is the distance. Okay, weight is 264. So I'll take, so let this be O. I'll take FBD at O. FBD at O. So see here. So what is the weight? Weight is 264. It is always downwards. So I'll take 264.6 Newton. ಹೌದಾ? ನೆಕ್ಸ್ಟ್ ಏನು ಬೇಕು? ಇಲ್ಲಿ ಟಿ ಫೋರ್ಸ್ ಇದೆನಾ. ಸೊ ಐ ವಿಲ್ ಟೇಕ್ ಟಿ ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 294. ಓಕೆ, ಮತ್ತೇನಿದೆ ಫೋರ್ಸ್ ಇಲ್ಲಿ? ಎರಡೇ ಫೋರ್ಸ್. ನಾವು ಐ ವಿಲ್ ಅಪ್ಲೈ ದ ಆಕ್ಸಿಸ್. ಓಕೆ, ಆ್ಯಂಡ್ ನಮಗೇನು ಬೇಕು? ತೀಟಾ ಫೈಂಡ್ ಮಾಡಬೇಕು ಇಲ್ಲಿ. ಹೌ ಟು ಫೈಂಡ್ ತೀಟಾ ಐ ವಿಲ್ ಟೆಲ್ ಯು ಬಿಫೋರ್. So this is the force. Now what we want only the how much is theta, and we last what we have to find h, height. So what I will do is I will find sigma vertical is equal to 0, taking upward as h2. Okay, so what will happen? Minus 264.6 plus this t component theta. So this is t sin theta, this is t cos theta. So we have to resolve because it is inclined. Plus t sin theta will be there is equal to 0. So what I will get is 264 0.6 plus we know the value of t 294 sine theta is equal to 0. So I can find theta. Yes, theta is equal to this is 264. I'll send that side. Okay, 264.6. okay, here divided by 294. This is sine theta. So sine theta is equal to what? 2. I'll send this to the same simple mathematics. Now theta is equal to sine inverse of this one, 264.6 divided by 294. So that will be 64.06 degree. So this is the theta, 64.06 degree. So 64.06 degree is the theta. Now what is this? So it's 90 degrees. So 90 degree minus 64.06. How much will get? 25.94. okay, 25.94 degree. This angle is 25.94. Now to find h, which concept we will use? We will directly use tan theta. Tan theta andrenu this tan theta opposite by adjacent. Tan theta andrenu opposite andre ಎಷ್ಟಿದೆ? 375 divided by h. So ಏನಾಗುತ್ತೆ? h is equal to 375 divided by tan of 25.94. So h is equal to, calculate my dear friends. So tan 25.94, tan 25.94. So 375 divided by answer is, it is h is equal to 770 meter. So by this way we can use the concept of equilibrium of forces to find the height. So when you think of application, you will find out why this type of problems have been given. So from this I'll conclude this lecture. So we have solved all the problems which are coming under the Lami's theorem and equilibrium forces concept. Okay, thank you.